Okay, so if we are using the logarithm, the functions of log, natural logarithm ln, and by using the implicit differentiation, if we are imagine this ln becomes the e, okay? So we can rewrite this log with terms e, and then we can solve this by using the implicit differentiation. So x become 1, and e with power of y is become e power of y, and multiply with d over dx. Okay, and then we can solve this, and it's resulting in 1 over x. Okay, and if we are using the similar method with different base, okay, so this is the base of e. The right one here is just any number b, with base any number, and we solved through implicit differentiations, and we got that the result is 1 over x ln b. Okay, so basically this is a general formula for differentiating the log, okay? the log b, the log bx. Okay? So if you have a log bx like that, so we can have derivative is 1 over x ln b. So this is a general rule. Okay? So when b becomes e, becomes ln, this will be log e or just 1. So it's 1 over x. It's become this. Okay, and we can set up for another combination if you want. For example, if you have another functions that is u, and u is another function of x, for example, we can set up chain rule also. Similar with this one also, we can set up functions directly. Like it's actually similar. And using the implicit differentiation, we can also prove most of the derivative using the ln. And then implicit differentiation, we can prove most of the type of functions in, for example, the power rule. Okay, this is the power rule. We can prove using the implicit differentiation. Also, we can prove the product rule. And if you would like to try it by yourself, you can prove also by yourself the quotient rule. So that's what I want you to actualize or to try. So you can try, for example, you can try f over g. Try using the ln, and the difference will be, instead of plus, it will be ln f minus ln g. Right? And then you can start to differentiate, and it will goes by like this, and that would be the same. Okay, the same thing. Yeah. So you can also try this. So try this. And whenever you feel all the techniques, all the process, okay? And of course, it will help you to understand what's the derivative stage. Okay? I think it will be helpful. Eventually, when you are in answering questions, solving some calculus problem, sometimes we forget something, right? And if you remember just the core or just the concept, you can derive by yourself. And I think that will be better. Okay? I don't want you to memorize all the things in calculus, because calculus is not memorizing. It's more about understand the concept. Okay. So about the ln, there are some so if I have f of x is ln, let's say it's absolute of x. Okay. Now this is important. Okay, this is important. If I write the functions with absolute value like this, we can have two possibilities, right? It become ln x or ln negative x, right? And this will be depends on the x. And of course, when we derive both of them, right? One become 1 over x, the other one becomes negative 1 over x, right? And it should be multiplied with negative 1. Okay. Do you get it? Why? The chain rule. Okay. So here, let me maybe write clearly. So this is the functions ln minus x. So we derive that, it's become 1 over negative x. And I need to multiply with this, which is, and it goes by 1 over x. Okay. Now, if we look on these two results, it's the same results, right? The same result. Now, if we implement this and think backwards, like in the integral, that's why when we integrate 1 over x, we need to write ln with absolute value. Because it can be these two possibilities. It can be goes to ln x or ln negative x. Okay, that's just a notes. Okay. So when you have, let me check. Oh no. I think this. Let me put the drawing. This will be the ln, and this will be 1 over x. So this is the ln absolute value x. Okay. So we can say in the conclusions that f prime x is 1 over x for all x except x equal 0. And by conclusions, we can always take the derivative of ln absolute value x is 1 over x. Okay. This is, I think, one of the key for later discussion on integral. Okay. Now, if we goes through the definitions by limit. Okay. So f of x is 1 over x, ln x, sorry. We know that the f prime x is 1 over x. But what about the definitions? Okay. So if, or maybe if I put 1, then it's 1, right? Now we can use this to express the number e. Okay? So if we try to take the definitions of the derivative by limit, now this means that all the x will exchange to 1. Or to make it easier to remember, all the h I will exchange to x. This is just to see the form later on. Okay, you will notice. And the functions will be ln 1 plus x minus ln 1 over x, and then limit as x approaching 0, and then 1 over x. This will be ln 1 plus x. Okay. And the final form we get is x. We have ln 1 plus x, and I will put the 1 over x here. Now, because we set up the f prime 1 is equal 1, so that means this is equal 1, right? And if we remember if we have e, and if we imagine this e as e with power of 1, then this will be e, and then we can set up the limit. And by the limit property, we can set up the limit goes down here, and this will be ln 1 plus x 1 over x. And since e with power of ln, this will result in limit which is by definitions, that is e. So e will be defined as limit as x approaching 0, 1 plus x 1 over x. Actually, if you didn't change x if you didn't change the h with x, this will be maybe 1 plus h, 1 over h goes to 0. It's actually the same thing, but I want you to just to show in terms of variable x. And if we look on the graph, I think I have set up the graph here. This is the graph. And precisely at this point here, that is our e in numbers. And you will see that it doesn't really have a point, but we have the limit. We have the limit, but we don't really have. So that's why it is e is using limit, because at this point itself, we don't really have the point, but we have the limit. And if you look on how we get the number, we can try some x into the equations. Maybe because limit is getting 0, so we can try some number that is close to 0, maybe 0.1, maybe 0.0001, and we can get that the number seems we are getting 2.71828. And actually, like this e or pi, the decimals is still not complete until now. Maybe a few hundreds, but still, if we continue with getting smaller and smaller, we still get more numbers. And actually, there is still history or something that we need to uncover from like the irrational number, like pi, like e. It's not really as simple as you think, because we just really know like a small numbers from those irrational. Because if we take more and more and more, still has a number, and we still need to uncover. And of course, your calculator has a limit, right? The brain on your computer has a limit, right? So the more we have, the machine has more maybe processing power, like it has like really good like capacity for processing. I think it's better to compute something like this. Okay? So that's the E. Okay. Well, in calculus we use E or pi just as simple as we are observed. Right? Like in question we just use E, we use pi, but eventually, it's more than that. Okay? It's not as simple as just using E. And another way to look at the E is we can set up E in terms of if n is 1 over x, okay, and as x getting 0, then n is getting infinity, right? Okay, in terms of limit. Then we can set up E in terms of n, and we can exchange all with this. And this will be related to compound interest. Like if you put your money in a bank, if you use maybe every period of time, you will get like maybe some percentage for the interest. This is the formula actually. And that is actually one way to get, oh, we get something, a constant there, and okay, that's E. And eventually people will notice that there will be a number like this one from the compound interest. Okay? So if you learn like a little bit economics, finance, you will also learn E, because you will find E in every aspect. Because this is in nature. It shows up in nature. Okay? You learn statistics, you learn biology, you learn finance, you will get E. Okay. Okay, that's a little bit review of a log and the implicit, and also the number E. Okay. The next sections, I want you to look on. I've prepared just a screenshot of the exercise for implicit differentiations. Just want to make sure that we are on the same frequency. Okay? At least we know how to solve. Okay. Let's start with something not too complicated. Maybe this number 8. So we have x cubed minus xy squared plus y cubed equal 1. Okay, let's start together. So if we derive, x cubed comes 3 x squared, 3x squared. And how about this one? Yes, and then we need to have product rule. Okay.
So when we have x and another variable, means that we need to have a product rule. Okay. So imagine this is fg. So first, maybe we are setting up the, or my suggestions, if you are maybe you're afraid making mistake because of this minus plus the signs and maybe it will affect your calculations, I will always suggest you to take some time to take a bracket. It takes time, but it will be help you. It will help you to avoid mistake. So we can have, this will be y squared plus 2xy, and then divide the x, and then close bracket. Y squared is from, this is derived, and then multiplied by y squared. 2xy divided over x means that we are deriving y squared, become 2y, and then divide over the x, and then multiply by x. Okay. I hope you get the idea here, and I want you to, the point of expectation is you can do this as easy as you please. Okay. That's my expectations. And then plus y cubed becomes 3y squared, and then dy over dx, and then equal 0. And then the next thing you are going to do is we are grouping dy over dx on one side, and we are moving the other to the other side. Okay. Okay, let's take it slow. And we can take dy over dx, grouping all together. Maybe 3y squared first because it's positive, and then minus 2xy. And depends on the questions, maybe the question is asking dy over dx when x equals some number. Maybe you can just put the number here and find out the results. And usually if the question just given you x, then you need to find y. And you can find y by the question itself. Okay. So maybe you can put x here and then find y from this x. Or sometimes they given you also the y. Okay, so that's number 8. And what else? Any requests? Which number you want to solve from here? Maybe just make sure from this one first. Okay. Any requests? Which number? Maybe from here. Any request that seems maybe you are not sure that you can do that or you can solve it. Maybe we can solve it together now. Number 9 is this one? Okay. You can do that. Number 9.
Number 17.
17. Okay, maybe number 9 and 17. Okay. Maybe number 9 I can do maybe here. Number 9 is x squared x plus y equal y squared plus 1. Okay, so if we look at on the function or the equations, if we are taking the dy over dx both sides, let me shift this a little bit, goes right here. And usually I just write ddx like this, meaning that we want to differentiate the left and right, okay, both at the same time. So first, if we look on the equation on the left, we have a fraction, okay, or a rationals. Okay. X squared and then x plus y. Okay. The first thing that came up to mind is using the quotient rule, right? So you can imagine this as f over g. Okay, and the right one is, I think, easy to follow if you want to derive. Maybe we can start from the right side, not too difficult here. So we can start with 2y and then dy over dx. Or if you want to write in terms of like not dy over dx, just y prime, that's also okay. If you feel that maybe this one makes your paper looks complicated, maybe you can just use y prime here. It's okay. So, okay, now let's do quotient rule. So quotient rule start with, let me draw the line, and then we can take the denominator with square, and then f prime g is 2x, maybe a little bit to the left, and then x plus y, and then minus x squared, and then 1 plus dy over dx. Okay, right? Okay, we can start to compute. So this will be 2x squared plus 2xy minus x squared plus x squared dy over dx. And this will be x squared. I will write down here. And then let's multiply to the right, cross multiply. Maybe write this first, x squared plus 2xy plus y squared. And let me write 2y, or maybe x squared y dy dx plus 4x y squared dy over dx plus 2y cubed dy over dx. Oh, I think we can just grouping the dy over dx all together. Dy over dx will be 2x squared y plus 4x y squared plus 2y cubed minus x squared. Oh, I think plus, oh, this is minus, sorry. I just realized that, so this will be plus, okay? And then the other side will be 2x squared plus 2xy minus x squared. Or we can, right? And then we can take dy over dx. This will be x plus 2y. And then we can write all the equations down here. Okay, and then that's the answer. Not really looking like a simple answer, but yeah, I think that will be the answer. Okay. Okay, I hope you get the idea how to derive. Okay, any questions from this one? Any questions? Did I make a mistake? Okay, maybe one more questions and then we can continue our discussion. So number 17, right? 17 is okay. 17 is 2x e with power of y plus y e with power of x equals 3. Let me take this a little bit right. And it's still the question's the same. We need to derive this. Okay, now this is a product rule. Okay, so FG. Okay, remember product rule, F prime G plus G prime F, right? Okay. So we can write 2 and then we can set up the F prime G. So maybe x become 1 and then G is just e with power of y and plus x, and then differentiation of e is just e, but you need to multiply with the chain rule. Don't forget the chain rule. So this is the first one. The second one will be F prime G and G prime F equals 0. So dy over dx will be 2x e y plus e with power of x, and then equal negative 2 e with power of y negative e x y. So dy over dx will be negative 2 y and negative y e with power of x, and then this will be 2x e y plus e with power of x. Or if you would like to write negative outside, factor it, this will be plus 2x e y plus e with power of x. Okay. Okay, and later I will maybe put some exercise for the implicit. I think from the beginning of chapter 3 until the implicit and log, I will give you some exercise. Okay, any questions? I think we can continue to now we will learn about the inverse of trigonometric. So inverse of trigonometric functions. Okay, so by definition, if we have y equal sine inverse x, okay. Remember, this is inverse, not the power with -1. Okay, that's the difference. So it's not equal with this. Okay, this is wrong. So inverse means that it's if we exchange y and x, this will be resulting in sine y is equal x. Okay. And for the inverse to be true, we need to have one-to-one functions. Okay? One-to-one functions, we need to have a certain y. Okay? That is maybe easy to start with -π/2 and π/2. This is because if we recall the sine it's always oscillating, right? And if we take the horizontal line, it's crossing more than one point. So if we set up maybe from this π/2 and -π/2, this is clearly we are just crossing only one point if we restrict the interval. So that's why we can have the sine inverse. Now if we have sine y equal x, okay. If we are using the implicit differentiations, sine become cos, right? Cos sine y, and then dy over dx, and x become 1. So dy over dx, we will have 1 over cos sine y. And through some equations, we are having for cos y positive greater equal 0, then we will have the same interval for y. And so we can set up cos y becomes 1 minus sine squared y. Or we can have 1 minus x squared. Or usually, I always suggest you to draw a triangle and let the y becomes your angle, and this will be x and this will be 1. Okay. Now this
particular sides will be 1 minus x squared. So from the triangle, we see that cos y is square root of 1 minus x squared over 1. Okay? So, at the conclusions, this is what we get. And again, I don't want you to memorize this final conclusion. What I want you to do is understand how we can get these expressions, especially using the visuals of the triangle. Okay? If you still feel that this will still overwhelm for you, okay, you need to review more. And I also think maybe we can have more practice on looking on the inverse. Okay? So we start from the sine inverse, okay? And we write the inverse in terms of sine y equal x, okay? Because it's sine inverse x equal y, and then we can write the inverse of that, becomes sine y equal x. Okay? And then using implicit, this is what we get. And d over dx is 1 over cos y. And since we want to have the conclusions in terms of x, then we are going to have this y in terms of x. And we get the x from either from this triangle, or you can just get from the formula here. Okay. Why I'm suggesting using the triangle? Because first, for me, visual sometimes is more powerful. And second, if you have the triangle, of course, the angle will be less than pi, which is most of the conditions for the inverse. Okay? So we can have those criteria in inverse. Okay. Maybe any questions first in terms of inverse? Anything to have, or sometimes some students may think today there's several types of students. Students who are maybe it looks fine and he can still understand the process. But there are also other students, maybe he doesn't understand the process. Or the third one, he doesn't understand what he didn't understand. You get what I mean? And if you are maybe the first time or second time, that's fine. You can still learn. But if you are in the third one, you don't know what you are not doesn't you don't know what you don't know. It means that you don't really understand all the things, but you don't know that you are not understanding. You know what I mean? Okay. So I hope you get the idea to become the first or the second one. If you don't know, like you don't know like which part, that's still good because you know how to study or which part that you need to learn. Okay? That's good part. Okay? That's good part. You know how to exercise, you know how to study. But if the third one happens, okay, then you need to review maybe yourself. Okay? Maybe you need to review what's your goal, what's your achievement, what you want to achieve in after graduations, or maybe what you want to look for. Maybe looking for a job, maybe anything can happen, right? So I think you need to review all those in yourself.
Okay, we can have a little break and then we can continue a little bit on inverse, and I think we can finish all the inverse for trigonometric for today, and maybe going a little bit afterwards to the next section. Okay, so I think we have a break now. Okay, so we learned about the sine inverse, and this is our conclusions. We can use the triangle, or we can just use the definitions of the inverse itself. And another one that is important is the tangent. So if we have the tangent, or maybe not need this. So let the y equal tangent inverse x. Okay. And similarly, we can set up this tangent y equal x. Okay. If we set up the implicit, this tangent will be a secant squared, right? And then multiply with the chain rule, and then equal 1. Or this will be dy over dx equal 1 over secant squared x. Now there are several ways we are looking over here. We can set up this in terms of it's not x, sorry, it's y. We can use the sine squared x plus cosine squared x is equal 1, right? If we multiply with 1 over cos squared x, all the terms inside, this will be equal with tangent squared x plus 1 over cos is secant squared x. Okay. Now we can simply change this into tangent squared y plus 1, or this will be 1 over x squared plus 1. This is we can get easily the results. Okay. Or if we want to try more visuals and looking at the triangle, we can also do the triangle one, similar to what we have done before. So this will be y, and tangent will be x over 1, like that, right? So tangent y is x over 1. Okay. Now if we have cos y, then this will be 1 plus x squared, right? Cos y will be 1 over, so the secant is just 1 over plus x squared, and the secant squared y will be 1 plus x squared. And it's the same thing with our results. Okay? So it's the similar result. Okay? So you can, looking on the identity from the secant, you can get the tangent. Or we can look on the triangle and we are seeing that, okay, it's the same result, 1 plus x squared for the secant squared. Okay? And I think this form is more, it's frequently or oftenly appear in the functions or in the calculus. Later on we can see on the integral, because sometimes we need to integral functions like this, and all we can do is we can transform into a tangent inverse. Okay, tangent inverse. There are other inverse trigonometric that is that you can also observe, but I think as long as you know how to to do the process, I think it should be fine. Okay, but maybe just 3 of them that I want to make sure that it's going to appear a lot at least. Cos inverse is just the negative of this sign, right? Okay. Because they are always in complement. I think just these 3 should be okay. The other one, like the secant, the cosecant, the cotangent, eventually you can get those expressions if you know the sine, cos, and tangent. So that will be the 3.6. Okay, so all of the logarithmic and inverse is 3.6. The next one, 3.7, I will just skip because I think it's more about physics and social science. And I think you can just read some part and learn in more details later on. So we can skip that, and we go to the related rates. Let me write here. This is 3.8. So what's related rates means? So it means that there are certain problems. There are some rates, okay, that is changing, and we need to find from one conditions, from one study case, what will be the correlations between one thing to another thing. Okay, for example, you have a balloon, okay. You pump the balloon, okay. You get the air, okay, and the volume will be changing, right? So it maybe is going like this after it's pumping. Maybe when the volume increase, of course it has time to, like this is maybe at t equals 0, and maybe this is t equals some time, okay, maybe several minutes. But when you calculate the volume change, we can have the rate of volume, right? We have the rate of volume. So let's say we have the rate of volume. We have the rate of volume, maybe 100 centimeter cube per second. And usually the case or the questions for the related rates is if we know the volume, maybe they asking how fast the radius is increasing. So probably how fast is the radius increasing when diameter is 50 centimeter. Okay. I hope you don't get confused on the questions here. Okay. How fast is the radius increasing when the diameter is 50 centimeter? Because it's the balloon will change its shape, right? And also we get the idea when it's changing, the radius also changing and it's increased. Right? But what the question means by at the radius of 50 centimeter is similar to what you learned in the tangent. Okay? This is similar when you have dy over dx at x equals something. It's similar. And like we, if you still remember the ball that is, we release a ball and it has some velocity, right? And we want to know the velocity instantaneously when t equals something, right? When t is really, really small. So this is actually similar to what we are already discussed. So which means that first we know that from the information, the air, maybe the rate of increase of volume is 100 centimeter cube per second. And our question, or the unknown, is the rate of radius when diameter is 50 centimeter. Okay. So the key here is, from the informations, we want to have some definitions. Maybe we define the volume as V. Okay. This will be the volume of balloon, and maybe the radius is the R, is radius of balloon. And all is going to have, they are all have the rate, okay? The condition of they have some time to, they have the interval of time, right? So we will have, the rate will be dv over dt. So this will be the rate of increase of volume. And we also have dr over dt, which means the rate of increase of r. Okay. So we can say that the rate of increase in terms of dv over dt is 100. And dr over dt will be our questions, right? This is the questions at r equal 25, right? At radius is 50. This is the questions. So we need to connect the volume and the radius. Of course, the volume has the radius in the formula, right? In the formula of volume. So in some part on cases in related rate, we need to have at least remember some geometric, either area, either volume, and sometimes it was given in the information as the information in the question itself. But for some typical geometric, I think you need to review by yourself. So for example, this balloon, this spherical balloon, the balloon will have the volume 4 over 3 pi r cubed. Okay. So this is how we can relate the radius and the volume. Okay. So this is step by step on how we understand the related rates through some concept. Now from here, we can relate to this dr over dt. How we can relate the dv over dt and dr over dt from the volume of sphere? Now we can use the implicit. We can use the implicit. Or we can just say not implicit, maybe just derive this volume. Okay, derive this volume with respect to t. Okay, so we derive with respect to t. So derive like that. Now this will be resulting dv over dt, or we can look dv over dt as the chain rule from this formula. And I think this is also similar with what we did here. Okay, so we can have this is 4 pi r squared and then dr over dt. And now we can have correlations for dr over dt is dv over dt divided by 1 over 4 pi r squared. And this will be 100 divided 4 pi r squared. And at r equal 25, this will be 25 over 25 squared pi, or 1 over 25 pi. So the rate of the radius will be 1 over 25 pi centimeter per second. Okay, I hope you can get clear explanations on how we can correlate some terms with another terms. Okay? For this case, we are using the formula for volume, sphere volume. So the idea of related rates is we are given some rates and we want to find another rate, and those two are they are having a similar connection. Okay? They are having similar connection, either using the volume, area, or maybe some formula that is specific, maybe like Pythagorean formula, distance formula. It can be connecting as well. So I think as long as you can define the problem and define which formula you are going to take, I think the differentiation part or the derivative part is not too complex. It's not too complicated. The difficult thing is the first part here, how to define or how to correlate one term with another term. I think that's the problem with related rates. If you miss something here, of course, from the middle until the end, maybe you will get wrong conclusions. Now, if we have another example that is a typical classic related rates problem is if you have the ladder. So let's say this is a wall, and you will have a ladder. So imagine this is a ladder. So it's a ground, and this will be a wall. you put your ladder here, and sometimes if it's not stable, it will goes down, right? Okay, imagine the problem. And what is happening is there are different perspectives on how we are going to look the velocity here, the rate here, and the rate here. So it has two different rates. Okay, it has two different rates, but they are, of course, when this is increasing over there, this is decreasing, right? Okay, so let me just give you some problem here. So a ladder, let's say 10, the example using feet, 10 feet long, rests against the wall. If the bottom of the ladder slides away from the wall at a rate of 4 feet per second, how fast is the top of the ladder sliding down the wall when the bottom is 6 feet from the wall. Okay. So this is 10 feet. 10 feet ladder. Let me write this is 10. Okay. Now the bottom of the ladder here, it slides away, okay, at a rate of 4 feet per second. So let me write here, this is 4 feet per second. And the question is this one. How about rate of from here? Okay? So how fast is the top of the ladder sliding down? Okay. Sliding down when the bottom is 6 feet, when this is 6 feet. Okay. Some mistake when we are looking this question or this problem is, one, you are mistaken that you put 6 as your fixed constant here. So you have 6, 10, and you know this will be some number using the Pythagorean, right? It's 8, right? It's 8. Okay, that's correct. But if you want to observe through rate of change, then you need to observe first. This should be the one that is changed, right? This is also the one that is changed. We need to observe that first before we put on our constant. Okay? That's the idea. That's why it's called the related rate. It's all about rates. It's all about rates. So when you have this question, do not put 6 as a constant at the beginning. That will make the conclusion will be a wrong conclusion, okay? Because that is not the goal of our question. The goal is we need to connecting the rate. That's the first thing. Connecting the rate first. Okay? Connecting the rate. So let's connect the rate. Let's say to make it easy, usually we are naming our variables. Let's say this is x, this is y. Okay? To make it easy, to be observed. So if this is x, then this will be dx over dt. Okay? It's over time, right? So this will be dx over dt. So this question here is actually asking dy over dt. And now we are connecting x, y, and 10. And again, do not put in the constant. Okay? Do not put the constant. So to connect x, y, and 10, we can just using the Pythagorean. So we can have x squared plus y squared is equal 100. Okay. Okay. Now we can take this, differentiate with t. Okay. So x squared become 2x, and don't forget the x dt. It's similar with what we did in implicit differentiation. And y squared will have 2y dy over dt equals 0. Okay, let's solve using dy over dt equal. This will be negative 2x 2y dx over dt. Or we can write negative x over y dx over dt. And now when we have the connections, then we can put on the numbers. Okay? We can put on the numbers. So at x equals 6, we have y equal 8, right? So dy over dt will be negative 6 over 8, and dx over dt is 4. So we will have 6 over 2 is 3, so it's negative 3 feet per second. And now we are wondering, why it's negative? Anybody? Yes. So what it means is actually positive or negative. You still can answer with positive as long as you write down the definition of the positive or negative, because both are true. Both are true in some perspective. Okay? But let me just give my perspective here. Okay? If we want to define that sliding away is a plus, when you have plus sliding away, you have longer, right? And here it's become shorter. That's why it's negative. But if you define that this should be a negative, then you'll be a positive here. It's still okay. Still okay. Both are true. So it depends on how you define what positive and negative means. So that's you get that the result is a negative 3 feet per second. Yes.
If x equal to 6, how y equal to 8?
Oh, it's from the triangle that before I mentioned that if this is 10 is a constant, right? So when this is 6, this is 8, right? Well, this should be longer. Okay, so the key for the related rates is, first you need to understand the problem. So if you maybe the question seems not clear, maybe you can pinpoint or mark some words that is maybe makes you confused. Okay? And then if there are some specific words that relate to, oh, this is the rate of change, you need to mark that words. And maybe if they given numbers, you need to pinpoint the numbers. So after you read the questions, you know the goal. The second step is draw a diagram. Okay, so first is read the questions. Read carefully. The second step is draw a diagram. And the third one is naming. Okay, can name with a variable with a, b, x, y, okay? And then express in terms of derivative or rate of change. Like if you know that is change, there is a change in volume, then we know that it will be dv over dt, right? Okay. And after expressing, write connection between rates. Or this is how we can relate the rates and thus become related rates, okay? And after we write the connection, we can use the chain rule or just differentiate, okay, differentiate the equation with respect to t. Or we can write that this is d dt, okay? And then substitute and compute. Usually this is all given in the information, so you can just use the number and then compute at the end. And I think most of the problem will have same concept. Okay? So first, read carefully. If you need to draw the diagram, so you need to maybe see more perspective from the drawing. And then name the variables. You can name it any variable you want actually. So x, y is actually you can change to any variable you want. And then you need to marking all the rates that is given in the information. And you can express in terms of derivative, dv over dt, like that. And then write connections. Usually when you write the connections, usually you write the formulation. That would be volume, area, okay. And after that, differentiate those equations with d over dt, okay, with respect to t. And after you got the results, you can substitute and compute the goal, your goal. Okay, so you need to get your results, okay, at the very end. Okay. Let me give you another, maybe one or two example. And later on, I think it will be very interesting if you can try by yourself for some problem. Okay, let me give you an example. A water tank has the shape of an inverted circular cone with a base radius 2 meters and height 4 meters. If water is being pumped into the tank at rate of 2 meter cube over minutes for 1 minute. Find the rate at which the water level is rising. When the water is 3 meters deep. So you need to understand the question first. You have a water tank. It has the shape of an inverted circular cone, which means it is a circular cone, but it's inverted. Okay. You switch the cone upside down. You have the radius, you have the height. Okay. So that means the water tank is constant, right? Water tank is constant. It's not changing the shape. The one that is changing is the water inside, because the water is pumped. Okay. When water is pumped, it has certain rate. Okay. It has certain rate. Let me just marks all the information, and then your goal: find the rate at which the water level is rising. Okay, so if this seems not really obvious, then maybe you can draw the cone first. You can draw the cone. Okay. You can draw the cone and name the variable first. Name the variable, and you will know what is your goal. So the inverted shape will be, this is the, I think this, okay, let's say that's our cone, inverted cone. So first, we can set up maybe this is just, we can set up that this is the radius 2, right? And we have the height 4. Okay, that's our constant. And then we have the water. Okay, so the water is being pumped. So the water is being pumped, and maybe this is the conditions at certain height of the water. Okay. So we have inside is the volume of the water, right? The volume of the water. So the water being pumped at the rate of 2 meters cubed per minute. So the volume of the water is changing with this, right? The volume of the water is changing with this 2 meters cubed per minute. Okay. We can say that this is the rate of the volume, or dV over dt. We can say that this is dV over dt. Okay. But before that, maybe we can simply name our variables. So if this is the water, then we have another radius here, another radius r, and another height. Another height, let's say h. This is my terms for naming the radius of the water and the height of the water. Okay. And because it started with the minutes, then when we calculate, when we get the terms dt, we will using the minutes. okay, using meter, minutes, okay, for the units. Okay, the next thing is the volume of the cone. So volume of the cone is 1/3 by r squared h, right? Okay. So most of the geometric, like cone or like a pyramid, we are calculating the base multiplied by height. Okay, now we are looking at, there are radius and there are height. These two are different, right? Different. Now, how to make the connections between the radius and the height? We need to have another way, it's aside from just looking at the volume, because this is clearly different, right? So we need to define with another method. If we look on the cone, the total cone here, we have this is 4, 2, 8, and R. We have a connections there. We can use the triangle property, right? Okay, if you see, so we can have that if you're looking R over H, okay, this will be results in 2/4 by looking at this triangle, okay? So R is half of H, okay? And this will help us to define this R squared H. You can define R as H or H as R. So you can substitute each one of them. Well, it depends on what is the question, right? The question is asking the height, right? The question is asking the height. Let's see here. Find the rate at which the water level is rising. So it means it's asking dH over dt. Okay? So I think it would be better if we exchange the R. So we are looking for the height. So V is 1/3 pi. Or we can say that this is this is 4, sorry. So we can have pi h cubed. And now from this volume, we can differentiate with respect to t. Okay? And thus we get dv over dt. This is pi. 3 with 4, this is over 4 h squared dh over dt. And this is the one we are looking for, dh over dt. So we can write dh over dt is dv over dt. This is 4 pi h squared dv over dt. And we know that dv over dt is 2 meter cubed per minute. And h at h is 3. So h is 3 meter. This 3 meters, this is h. So we are exchange all the terms. That is, this is 2. Oh, I am never writing here. Okay. So dv over dt is 2. Maybe 4. This is 2. Or this will be 8 over 9 pi meter per minute. Okay.
Okay. So I hope you get the idea behind it, because this is a difficult problem that you need to at least familiar. Because at least this is just the standard level for you to solve.
Okay, any questions?
So this is the related rates, and probably next Friday, maybe I will give you another example. Like you have the ladder, the volume, and the usual case is the car that they are going to drive and then meet at some point, and also the shadow. That's the typical question that always repeated all the time. So the shadow will be like, you have the lamp over there, and you are walking, and you have the shadow that is stretching, and it has a rate of change as well. And you can look for some correlations, and I think after the related rates, we can move on to next sections about linear approximations. Okay, and hopefully after linear approximations we can move on to the new chapter, which is more about sketching a graph with the help of all the calculus, especially the derivative. Okay, and I think we will have, because we will have long holiday, right, at the end, at the first week of April, and the schedule actually for the university, they are having the midterm after that. But I think for our class, I think it will be better 1 week after that. So maybe in the middle of April we will have the midterm, and the content will be from the first chapter to the sketch graph later on. Okay? So chapter 1 to chapter 4. That's the content for the midterm. And before the midterm, or maybe before the holiday part, maybe we'll have one more quiz. So maybe next 2 weeks. And the content probably about chapter 3 maybe for the quiz. Chapter 3. Okay, I think that will be our class for today. So see you next Friday.